So here is an example, typical example of how to solve problem related to projectile. Here I have a ball on the building, and I'm going to launch this ball horizontally with V0y parallel to the x-axis. The question is, what is the time required for this ball to hit the ground? The initial conditions are V0 2.4 meters, and it is located 0.6 meters above the ground. Now, before we solve this kind of problems, we have to be clever how to solve and how to start this kind of problems. First, we have to be clever. We said in the previous section, we need to eliminate x0, y0. So I'm going to associate a coordinate system just at the launching point, and therefore the increasing values are up and in this direction. So therefore, in this case, x0 equals y0 is just 0. A very clever choice. Very clever choice. Now, the ground in my coordinate system is located at minus 0.6 meters. So let's write the equation here, y of t. The y component at any given time would be y0, which is 0, and I have v0y, which is also 0. I have now y component of v at the beginning, then 0, and then the last one is minus half gt squared. This is y at any given time, here, till it hits the ground. Now, obviously, when it hits the ground, y is just minus 0.6 meters. That's at the ground. At that time, it is minus half. G is 9.8 meters second squared times t squared. Now notice minus minus, I can multiply negative 1 and get rid of negative. Multiply 2 and divide by 9.8, just divide and have 4.9 and solve for t squared. So t squared is just square root of 0.6 divided by 4.9. This will give you a value this is t. Will give you 0.35 seconds. Notice that since you have t squared, we expect two values. We always dismiss the negative value, it is not physically meaningful. So this is the answer to our question, what is the time required for this particle to hit the ground? So the y component will give you that answer. Now what is interesting about the projectile is that the time t for the particle to go from this point to the ground is exactly the same time for the particle to move this point to this point. That means the time, vertical time, is equal to parallel or horizontal time. It is the same time. And therefore, it is always nice to figure out t because it is common parameter to solve any problem. So time probably is the best way to go. Now, we can ask another question. What is the range? That means the landing point from this building. What is the range? Well, to find the range, since it is the same time, then I can use the value of x. It is v0 cosine theta t. But theta here is 0, and cosine 0 is 1. So this simplified x is just v0 t. So the whole vx is just v0. Vx is v0. And so now x is 2.4 times the time. It is 0.35, and so that is 0.84 meters. Notice I did not use here the units because I'm working on a SI system. The outcome will be just fine. So that is a typical problem related, I'll say it, with projectile. So the first thing to do is associate a coordinate system at the launching point. That's the first thing. The rest is algebra. Everything against your choice will be negative, along your choice is positive. Use two equations. These are equations are true along the x-axis and y-axis. Time is a common parameter. Always think about time, and the rest is algebra. This is a typical question. Other question we may ask you, what is the highest point? Also, remember how to solve a quadratic equation. This is something part of our background. And so that's about it.